Okay, let's try this one. And this is a little bit trickier because we have our a value, the leading coefficient is not 1, which makes it harder to complete the square. So the first step I'm going to have to do, well, let's first move this over, because that's what your teacher wants. You don't have to do this, but that's what your teacher does. And at the same time, let's factor out an x squared. Let's factor that out.
So that would be 4.
So taking an x squared out of there is like that.
Oh, because 1/2, like 8 divided by 1/2.
Right, because that's right, because 8 divided by 1/2 is 16. Just to check it, just kind of plug it back in and see if that gives you this, and you'll see that it does. Got it?
Yeah.
Okay, now what am I going to do? I'm going to put, remember what I showed you before? You're going to have to add half of this squared.
So that'll be 8 times 8, 64.
I'm going to add 64, but am I really adding 64 to this side of the equation?
No.
No, I'm actually adding half of 64.
Yeah. Oh.
So I have to add half of 64
32
to the other side. So I'm adding 32, that's right. So my answer is y plus 9, because 32 minus 23 is 9, equals 1/2 times x plus 8 squared.
Oh, I see.
So there's my vertex form.
C, you have to factor by the 8.
That's right. So when you factor it out, just make sure that you keep that number when you're adding it to the other side, that you also consider that factor in it as well.
So like if a equals 1, you don't have to do that.
If a equaled 1, you didn't have to do that, right? But if it equals something else, you had to. Okay, so now let's talk about how to graph this. This is a little bit trickier. So first of all, notice that my vertex is equal to -8. Remember, it's the opposite of what's there and the opposite of what's here. -8, -9. But also notice that it's the a value is 1/2, which means it's going vertically. It's being compressed vertically by a factor of 1/2.
So like y times 1/2, y value.
Yeah. So let me show you how you would look at that. So let's say this is my graph right here. It's negative. What was it? -8, -9. So -8. 1, 2, 3, 4, 5, 6, 7, 8. There's -8, -9. 1, 2, 3, 4, 5, 6, 7, 8, 9. It's right here. That's my vertex. Now, normally, I would go over 1. Remember what a vertex would normally do? It'd be, or what a parabola normally does? It goes over 1, up 1 in both directions. If you go over 2, it goes up 4 in both directions. Okay, so I always like to draw it. Whoops, I did that one wrong. That's your normal graph. I always like to draw on like a kind of like a dotted line. I like to draw a dotted line in just so that I can see kind of the axis of symmetry, right? That's the normal graph. But remember, this isn't the normal graph because the a value is 1/2. So instead of going over 1, up 1, it's going to go over up 1/2. So 0.5, it's going to be multiplied by a factor of 1. Instead of going over 2, up 4, it's going to be half of 4, which is 2. And instead of going over 3, up 9, it's going over 3, up 4.5, right? So somewhere like this. You understand?
Yeah.
So the normal graph would have been this right here. It would have been like that. Excuse my
if a equals
shaky.
1.
If a equaled 1, but since a doesn't equal 1, since a equals 1/2, it's compressed. It's compressed by a factor of 1/2, which means the vertex is the same, but the graph goes up half as fast. That's what vertical compression looks like.
I see.
So that's your graph, and you can test it if you want. You can test by plugging in a couple points to make sure that they're correct points. It's always wise to do. So this point right here, plug in 1, 2, 3, 4, 5, 6. -6, -8. See if -6, -8 is on your graph. If I plug in -6, do I get -8 here? Does that work? -6 plus 8 is 2, squared is 4, half of 4 is 2. Uh-oh.
And -8 plus 9 is 1.
-8 plus 9, maybe it should have been -7. Yeah, I counted wrong. It wasn't -8. This is -7, not -8.
Oh, okay.
So that did work. Got it?
Yeah.